Yeah, very good afternoon to all dear participants. In the third session of fifth day of this short-term training program on artificial intelligence and 5G communication technology, I am pleased to welcome Mr. Sanjay for the session speaker at that STTP right now. He is with us. Dr. Sanjay, Mr. Sanjay has electronics and telecommunication professional having total 17 years of experience in telecom and 12 years of experience in the domain of IP and cloud. In training delivery, about 50 countries like 2G, 3G, NGN radio, packet core network, IP fundamentals, and network for Nokia, Ericsson, ZTE, Samsung, and etc. He has also certified with AWS Solution Architect Associate and certified with AWS Authorized Instructor AAI also. He is having the experience with 2G and 3G products like Flexi BTS, Ultraside BTS, BSCs, AXC, Facin and Flexi Hoppers. So it's a great honor to have as a speaker for this session. Welcome you, sir, and over to you.
Okay, so shall I get started?
Yeah, sure, sir.
I hope I'm audible to everyone. If any questions, any issues, do let me know. My voice is loud and clear. So thank you very much, Payal ma'am and the Garima ma'am for the introduction, the nice introduction what I had. Just allow me a minute. I'll share my screen and then we'll get started. I hope you are able to see my screen.
Yeah, sir.
Okay, great. So let me get started now. So thank you very much for the nice introduction. I'm a little nervous today because so many eminent speakers have spoken before me and I have to do some justification to these 90 minutes that I'm going to spend here. I'm not a very educated person like you all. I'm a plain BE as an engineer. I'm only engineer, so I have just learned things by doing. Right, so I have so many different doctors and speakers have spoken before me, so there is a lot of responsibility on me to spend these 90 minutes to make some difference to your knowledge, right? So let me try my best to do that. I will be keep on sharing multiple information, and then if you have any question, because I'm not able to see the chat box, so if any questions are coming in between, please try to unmute your mic and start speaking, because I will not be able to see the chat boxes, so I will not be able to read the messages. So anything, please interrupt and ask questions. So in this section,
sir, excuse me, sir. Sorry to interrupt you. Actually, I want to state that in the meanwhile, if participant unmute itself individually, so it get interference. So it will be better for us.
Sorry, I was talking about you. If any questions are there, you can ask questions in between. Yeah, interrupt me.
Or after 3:10 or 3:15, we will take the query session in the end of your session.
That's okay. That's perfectly all right with me. All right. So that's perfectly all right. Okay.
Yeah. Okay.
So now let me get started. Just give me a minute. Okay. So this session is I'm going to talk about the 5G core network and AIML, artificial intelligence and machine learning. So many different sessions. I was looking at the schedule and so many people have already spoken about it. I will try to just do justice to this subject as far as I understand these technologies. So before we get started, my name is Sanjay Kumar and I work for a company called as NanoCell Networks. So this is me, Sanjay Kumar, and I have 18 plus years of work experience. Talking about organizations, I'm currently working with NanoCell Networks, but briefly I have worked with many other organizations like HFCL, Reliance, Hutchison SR, Ericsson, Nokia, and some companies in Finland. Technologies, I've worked with 2G, 3G, 4G, 5G. I've worked with transmission networks, IP, core, VAS, cloud, and I have worked with AWS as well. So there was some correction. The Payal told I'm working with IBM Cloud, but I've not worked with IBM Cloud, but I have worked with AWS Cloud. The telecom products I've worked with is Samsung, Nokia, Ericsson, ZTE, Cisco, and AWS products as well. And this is my email address, sanjay.kumar@nanocellnetworks.com. I'm also available on this particular mobile on calls and WhatsApp, so I'm just sharing my details here. And my LinkedIn profile here, where you can find me with the name of Sanjay Kumar, and it is I'm pretty active on social media, so you can find me on social media as well. So before we get started, most of my experience has been as a corporate training. But I really very enthusiastic about teaching students and the college students, and I have personally trained the students in more than 100 colleges across India. And Poornima being one of them, so I've been to Poornima College for some sessions on telecom. So I'm pretty excited to teach students and the faculty members, and that's where my passion comes into play. Yes, I do corporate training, but that is more of a compulsion for bread and butter. But I'm more enthusiastic about teaching students and the faculty members. So that's where my interest lies. However, to do other things, like I have to go with corporate training. So most of my experience has been into corporates and the corporate trainings. So currently I'm working on 4 different ventures, which is like one is nanocell network, which I've already spoken. Under that, we are working with another one called as Lanizo Global. So nanocell networks is a telecom training and consulting company. We serve like companies like Ericsson, Nokia, Qualcomm, Accenture, Wipro, and many other organizations. Lanizo Global is a new formed vertical where we talk about IT training and consulting. I'm also a cloud enthusiast, so I'm building a community of cloud learners and cloud trainers, and that is called as Cloud Training Guru. So I will be sharing some links to so that you can know a little more about it. And I'm also very enthusiastic about the kids of the education for the kids. So I run a portal called as Tech Fund to Kids, where I actually train students on the basic computer skills like HTML, Python, as well as something related to IoT and stuff like that. So these are, if you see, my world revolves around learning and teaching. So I love training corporates. I love training students as well as the kids. So like I keep on doing various student programs as well, various cloud trainings as well for various people. So this is what my interest lies. So my whole world revolves around the learning and training. So let's get started with the session. And before we get started, I'm sure many of you have already seen some of these pictures. So this talks about 3GPP evolutions, 3GPP, which is called as third generation partnership project. However, it talks about third generation, but typically they cover all the generation till 5G. I will not talk much on 1G, which was typically analog devices and analog networks. 2G, which was a digital services where we started with GSM, which is Global System for Mobile Communication, GPRS, General Packet Radio Services, and Edge. We moved on to 3G, where we actually had something called as WCDMA. Here we were having GSM, and here we had something called as WCDMA. In WCDMA, we implemented UMTS initially, and then we went ahead with HSPA, high-speed packet access, and the high-speed packet HSPA plus. So I'm just skipping all those things. If you have any questions related to these stuffs, please feel free to ask those questions, because I'm assuming that you are already aware about these things and you have already covered these subjects in some of the previous sessions. So I'm not speaking much about it. However, yes, we are going to talk a little bit about LT and LT Advanced. And finally, how we evolved into 5G, where we talk about downlink data rates of 20 Gbps and uplink data rates of 10 Gbps. So we typically call it 2010, 20 Gbps of downlink, and 10 Gbps of uplink. So we will talk about it, what are these data rates and how we can actually achieve all these things, right? So, but just to give an idea, in 5G and its evolution we are talking about, where we actually have the different kind of architecture, different kind of services, different kind of service verticals. So this 5G has come as a big evolution to telecom world. Now, what are the major changes in the telecom world it has brought? We will really talk about it. But before that, we will talk about some other concepts of 5G, and then we will see what are the different changes this 5G and AIML has brought to the telecom networks. Telecom networks are no more same. So they're very different compared to what they used to be 4 years back or 10 years back, right? Because I'm working in telecom from last 18, 19 years. So I have seen the days of GSM. Of course, I'm not that old where I've seen analog communication, but yes, I started my career with GSM. So I've worked almost with all the technology what you see from here to here. So I've started working with GSM. I was the first. I was a part of the team which has deployed GPRS in Rajasthan for the very first time. So I used to work with Hutchison SR. So we did the GPRS deployment in Jaipur. So we did edge implementation, and I have worked with UMTS, HSP. So I found myself lucky that I've worked across generation. So it has been around 18 years. I've spent my almost complete my career on telecom technologies. So 2010 is something which is the downlink data rate, but 5G is much beyond that. 5G is not till now, till 4G, the only thing what we were talking about is data rate. 5G is not only about data rate. 5G is much more beyond that. So what are those things? We are going to spend a little more time on there instead of spending time on this particular slide, which is typically 3GBP evolution. So I'll just talk more about the what are the new things we are having in 5G instead of talking about all the history about 2G, 3G, or 4G. So I hope that's okay. And at any point of time, if you feel that I'm going a little fast, please feel free to interrupt and ask questions. So why 4G is not enough? So 4G, why it is not enough and why we are moving towards 5G, that is something what we need to answer before we actually move to 5G. So typically, these are some of the factors where we talk about 4G to 5G comparison. And in this one, the first one is mentioned at 10 to 100 milliseconds. The typical latencies, typically I say these are the radio latencies I'm talking about. They were in the range of 10 to 100 milliseconds in case of 4G. However, in 5G, we are expecting the latencies of less than a millisecond. So we are expecting latencies of 1 millisecond or less. That is something what we want to achieve with 5G. How we really achieve this, we will talk about it. But this is our expectation, that we want 1 millisecond or maybe lesser than that kind of latency. Download speed, where 4G talks about 1 Gbps kind of data rate. In 5G, we are talking about 20 Gbps kind of data rate. So this is what is one of the, I'll not say the only motivation towards 5G, but it is one of the main motivation towards 5G. We have much more than this. Frequency channels, we had 20 megahertz in LTE, and we had 100 megahertz in LTE Advanced, which is nothing but 5 channels of 20 megahertz each, which is typically called as a CA. CA stands for carrier aggregation, which is available in LTE Advanced. However, in case of 5G, we are talking about channel bandwidths of 800 megahertz. Please understand this 800 megahertz is the channel bandwidth, not the band. People normally get confused with this because we used to have 800, 900 kind of megahertz band in case of GSM. And people really confuse those 800, 900 megahertz band with this 5G channel bandwidth. So this is not the channel band, but the bandwidth. So we are going to talk about it. So this is typically, we have two different concepts in 5G, where we talk about FR1, which is below 6 gigahertz, and FR2, which is above 6 gigahertz. Right. So in FR2, we are talking about bandwidth, the bands which are typically 24 gigahertz to 100 gigahertz, and where we are expecting bandwidths of up to 800 megahertz. Right. So this is what we are expecting from 5G, because as Shannon rightly told, capacity is directly proportional to the bandwidth. So whatever we play with other parameters, bandwidth is something which is going to be a major game changer when it comes to the capacity of radio networks. So radio network capacity can be improved only when we change bandwidth. Of course, other things like MIMO, modulation schemes, advanced antenna techniques, they are also important. But the first and the foremost important thing for higher capacity is going to be the bandwidth. Nobody is going to change that. This is the typical architecture, typical characteristics of radio network. So first thing, but we need to change the bandwidth, and that is the reason we are talking about 800 megahertz kind of bandwidth. Core network of 4G were hardware dependent. So we used to have different network elements for each and every device or each and every network function. However, in 5G, what we are going to have, there is absolutely no definition about hardware-based architecture. So they only talk about cloudification of the network. Cloudification of the network means your core network is going to be completely based on the cloud. A radio network can be partial. Nobody can replace antenna system. Nobody can replace transmitters and receiver when it comes to the end user coverage. But there is something which even can be cloudified in the RAN part as well. And that is also called as CRAN. CRAN is called as Cloud RAN, where a portion of radio access network, CRAN is typically a portion of radio access network, can be cloudified as well. We will not spend much time on CRAN. We will not talk much about it, but this is typically one example I'm giving. So it's not only the core network which can be cloudified, even there are option of radio network which can be cloudified. And nowadays in the market, which is at the boom, is called as ORAN. ORAN is typically the open RAN, where vendors and operators are talking about open standards for RAN, where you can get hardware devices from any vendor. and can implement it on any network. So we are talking about Open RAN as well. Subscriber density, this is typically 10 raised to the power 5 subscriber per square kilometer, which we were expecting in 4G. In 5G, we are expecting around 1 million kind of subscribers. So we're typically talking about 1 million kind of subscriber per square kilometer. So this is something going to be huge in case of 5G, and that is required to support various service verticals. So what are these service verticals? We will talk about it in the next couple of slides. But 4G was mainly designed for mobile broadband services. However, we had some updates to LTE, which is later called as NB-IoT, which is nothing but narrowband IoT. But 5G is not designed for only for broadband. So EMBB stands for some broadband services, URLLCC is something else, and MMTC is something else. We are going to talk about all these things. So there are multiple service verticals which are defined in 5G. We are going to talk about what is the motivation behind these service verticals and what we are trying to achieve with these service verticals and how we really implement it. Because why I'm talking about this topic specifically, because AI and ML are going to play a major role in how these things are going to get implemented in the network. So implementing mobile broadband services was, I'll not say it was easy, but it was still manageable. But managing multiple services in one physical network, multiple services in one physical network is going to be difficult. How do we really manage it? We are going to talk about it. Okay, now these are the three service verticals what I'm talking about in the last slide. So let me just move this a bit. Okay, now if you look at this, EMBB, which is called as Enhanced Mobile Broadband, MMTC, which is Massive Machine Type Communication, and URLLC, which is Ultra Reliable Low Latency Communication. EMBB is typically nothing but broadband kind of services, which was already there in 4G. The only thing what we are having is higher data rate. So nothing innovative here. It's just higher data rate. How you achieve it? By having advanced antenna technique as well as the higher bandwidth. So nothing great here. So it's just following the same pattern which you were following from 2G to 5G. MMTC is more or less the same, which was like NB-IoT. NB-IoT, which is called as Narrowband IoT, which was implemented in LTE network. It is nothing but massive machine type communication where we are implementing IoT kind of services. However, this is something which is pretty new to 5G, URLLC. In previous generation network, we never had these kind of services, ultra reliable and low latency communication. And the kind of use cases they bring in, they are entirely different. So they are talking about industrial IoT, they are talking about autonomous cars, they are talking about B2B communication, V2X communication, tactile internet. So all these use cases are typically new for the 5G system. So this ultra reliable low latency is something which has brought a new life to 5G network. Now, why we are talking about it? Because the broadband, when I talk about 20 Gbps kind of data rate, that is something which cannot bring a lot of new customers. So we get more money when we bring more customers to the networks. So URLC comes with a separate use cases and which enables us to have new devices, new services in our network. So they are planning to have around 50 billion connected devices. They may be connected by URLCC kind of services or MMTC kind of services. So mobile broadband, today I'm already using 2 mobile phones. So I'm not going to make 10 mobile phones if I get 5G. So my 2 mobile phones are going to be two mobile phones. But if I really need to add more devices, I have to work more on these services, which is MMTC and URLCC. So URLLC, ultra reliable low latency communication. Let's talk a little more about it. EMBB is nothing but high rates, enhanced broadband, tactile web, HD video call, and it is also called as FTTX alternative. We call it as fiber to the X, but they also call it something called as wireless fiber. Wireless fiber means wireless network with the capabilities of fiber. So you can afford to have fiber kind of data rates because 20 Gbps we never expected in wireless network, 20 Gbps. So we never expected these kind of data rates in wireless network. That is why we are calling it as wireless fiber. Wireless network with the fiber kind of capacities. That is what we are trying to achieve. in eMBB, 20 Gbps of downlink, 10 Gbps of uplink. Please understand these data rates are the network peak data rate. Typically, consumer experience data rate, we are expecting around 100 Mbps, where every user will be able to get 100 Mbps kind of peak data rates. So these are the network data rate, 20 Gbps downlink, and these are the user peak data rate of around 100 Mbps, which we are expecting in 5G. MMTC, larger number of devices, anything, my car, my washing machine, my microwave, my watch, my anything and everything can be connected to internet today. And we are expecting larger number of devices to be connected to internet, but it requires deeper penetration and the devices has to be power efficient. To do this, we have brought in a lot of new features into 5G. One of those important features is called as MICO. I'm not sure if you have heard about it. It is called as mobile initiated connection only. Mobile initiated connection only because there is a street light. Let's say I am connecting a street light from some IoT device. Now, do I really need paging for this street light? Do I need location update? I don't really need these things. And do I really need to have some location updates and other stuff? I don't really need it. So in this scenario, we typically talk about something called as MICO, which is mobile initiated connection only. So they will send some data. So there can be some sensors who needs to send some data to the network. So these connections are only initiated by mobile. Network cannot ask those devices to make a connection. So it cannot be any services, no paging required, no location update required, no updates required at all. So you can have very, very power efficient kind of devices. So this is going to be a very interesting use case for 5G. V2X is another interesting use case where we talk about low latencies, low latency less than 1 millisecond kind of latencies, high reliability, highly reliable network, and typically applicable for V2X, V2V kind of services, which is called as vehicle to X, and PS, public safety app. Public safety typically called as MCPTT. MCPTT is called as mission critical push to talk. Typically emergency services 100, 102, 1110, 110. So these are the typical railway. So for LTE, there is a version called as LTR. LTR is called as LT for railways. They have different implementation for railway network. However, in 5G, there need not to have a different implementation. The traditional networks can support your PS application, which can include audio, video, and a number of other services. So they have in R12 of 3GBP, R12 and R13, there was some special definition about PS applications, public safety applications. However, 5G is going to implement those applications by using URLLC. Now, let's move forward and understand a little more about these things. This is 5G network deployment, different options. This picture is taken from GSMA white paper. And these are multiple options. There are two different type of options called as SA and NSA. SA is a standalone architecture and NSA is non-standalone architecture. Non-standalone means, standalone means where it is only one type of radio, either new radio of 5G or LTE of 4G. In case of NSA, we are having coordination of two different radios where we have actually LT radio as well as the new radio, which is for 5G. So in option 5, typically if you look at this option 1 and option 2, this is nothing but LT network and this is nothing but 5G network end-to-end. No LT here and no 5G here. They are pure 4G and 5G network. However, if you look at this particular option, option 5, in this case, my LTE node B is connected to 5G core network, for which it requires an upgrade. I need to upgrade my LTE device and make it compatible with the 5G core network. Another option here is option 3, which is very popular option, where I'm using the core network of 4G. So I'm just reusing the core network of 4G. And I'm not having only any 5G core network, but I'm having 5G radio. So in this case, I have LT radio network as well as NR, which is 5G radio network. And in this case, my LTE node B is working as master and my 5G G node B is working as a secondary. So we have this node as master and this node as secondary. However, in option 4, it is other way around. my G node B, which is NR, is the master, and my E node B, which is next generation E node B, is slave, and they are both actually controlled by 5G core network. So we moved from EPC to 5G core network. In this scenario, option 7, the core network is again 5G, but in this case, my 4G base station is working as a master and 5G base station is working as a radio network. So this also gives a lot of options to the operators how they are actually going to implement these network elements. So it also allows you to reuse your network. There is a very, very interesting thing here. 5G does not define any interoperations with 2G and 3G. Please understand this. As of now, there are no standard definitions in 3GPP documents which defines interaction between 2G, 3G network and 5G network. But they define 5G network interaction with 4G, but not with 2G and 3G. So we really need to understand it. 3G is already getting obsolete. 2G, more or less, they want it to get obsolete. So what we may see in future is only either 4G and 5G. So we may not see, however, it may take time, it may take few years also, but they are looking at the option where 2G and 3G can be completely scrapped so that operator can save a lot of cost on the network management and network operations. So this is 5G core network. Before I talk about it, let me talk a little more about 4G core network. So just give me a minute. Okay. So in 4G core network, we had something called as MME. We had something called as S gateway. We had something called as PGW. We had something called as HSS. So MME, which is mobility management entity, S gateway, serving gateway, P gateway, PDM gateway, and HSS, home subscriber server. All these were hardware-based function. So they used to have hardware equipments. In those hardware equipments, you used to install software of MME, software of HSS, software of S gateway and P gateway. The typical implementation, they used to keep S gateway and P gateway in one box, and they used to call it as SAE gateway. They were all hardware intensive network. However, in 4G, at a later stage, they tried to implement something called as VEPC. VEPC is called as virtual EPC. Means all these network functions like MME, HSS, S gateway and P gateway, they can be implemented on cloud infrastructure. I can implement it on the COTS hardware, commercial off-the-shelf hardware. So I need not to buy these devices or hardwares from Ericsson or Nokia or Samsung for that matter. I can install these applications on the hardware of Dell, HP, or any other servers for that matter. So my hardware can be different, but my software applications can come from any of the telecommunication company. But now these companies has become software companies because they have to provide software applications. So that brings new challenge. All the software companies like TCS, Infosys, Wipro, Accenture, they also became a telecom company. So understand, in last 6 months, I have done almost 10 different programs, and none of those programs were done for telecom trainings. They were all done for software trainings like TCS, Wipro, Infosys, Accenture, Tech Mahindra, and so many others. So all the telecom companies are becoming software companies, and all the software companies are actually becoming telecom companies. This is the new challenge. Now in 5G, there is absolutely no option of hardware definition. Hardware definition itself is not there. It is completely cloudified, and this is how it looks like. Now, if I look at 5G core network, it is completely based on the cloud infrastructure. And all the things what you see on this particular picture, they are called as network function, NFs. There is absolutely no definition of network element. Network elements were typically physical network element. Now they call it as network function. And all these network functions are created by using something called as NFV. NFV is the technique of creating these network functions, and this is called as network function virtualization. And all these network functions now they are called as VNF. VNF stands for virtual network functions. That means all the boxes what you see in this picture, all the boxes what you see in this picture, they are not the hardware boxes. They are the applications. They are the applications in a cloud infrastructure. That is one. Secondly, because they are created as applications within the cloud infrastructure, they don't really communicate to each other with proprietary protocols. So what they do is they have a RESTful API kind of interface, RESTful APIs, and they typically communicate by using protocols like HTTP2. And on top of that, they use JSON scripting, which is JavaScript object notation. So what do we actually want to convey here? What we want to convey here is the telecom infrastructure is no more telecom infrastructure. It is actually getting into IT infrastructure. So going forward, what we see in the core telecom network, at least in the core network, radio network still little 50-50. But when I say core network is not going to be telecom infrastructure at all. It is just going to be IT infrastructure. All the protocols, all the procedure, everything can be used just like cloud infrastructure. That is what I want to convey here. Now, a little more about it. 5G RAN, we just talked about it. We typically called it as G Node B. G Node B is called as next generation Node B. Then we had MME. MME had multiple functions, and those functions are now divided into AMF and SMF. AMF is called as the access and mobility management function. Access and mobility management function, which is typically works similar to MME in 4G. SMF is called as session management function, which is the control plane. If you see this, the area above this line and the area below this line, area above this is control plane and area above this line is user plane. User plane is the traffic, the control plane is the signaling plane. So SMF is typically the session management function. So anything related to session has to be managed by session management function. UPF is called as user plane function, which typically takes care of the user traffic. And DN is nothing but data network, which was usually called as PDN or packet data network in case of 4G. Now, HSS, home subscriber server. Home subscriber server is typically now called as UDM, which is called as user data management. However, the authentication function is taken out of UDM, and now that authentication function is called as AUSF, authentication server function. So if you really need to talk about all these network elements and these things in detail, because we have a lot of time limitation here, we have a YouTube channel. I will share the link of that YouTube channel, and we have a very, very detailed session on many of these subjects, many of these topics. So I will share the link for that. So if you like those videos, you can actually subscribe to that YouTube channel. So every week or every second week, we keep on coming with new videos on some of these topics. So you can actually subscribe to those channels and you can get more detail about it. Now, in 4G, we had something called as PCRF. The name of PCRF is now changed, and now we call it as PCF. The functions are more or less the same, called as policy control function. NEF is something called as network exposure function. Network exposure function is the function which exposes the network capability of the 5G network to the third parties. Now, this is this is not an uncontrolled kind of network exposure. It is a controlled third-party network exposure where the network functionality can be exposed to the third party to provide enhanced consumer experience. So just to understand as a layman, you can consider this NEF as just like you are giving permissions to the application, that this application can actually access my voice logs, can access my photos, can access my contact list. Something like that, we are actually giving access, the controlled access of the network resources and the user data to the third parties so that you can get enhanced consumer experience. Just like when you want to use Google Maps in your mobile, you need to give the access to the location, then only you can use the Google Maps. So this is something similar to that. However, this also enables operators to bring new revenue sources. However, all these software applications are dynamic in nature. To have a directory of all these software applications, we have something called as NRF. NRF is called as network repository function, which will have a repository of all these network functions. And then we have something called as NSSF, which is called as network slice selection function. So we have a new feature in 5G, which was not there in 4G, called as network slicing. We are going to talk about it, so I'll not spend much time here on slicing. We will have a specific slide for that. So slicing is one of the new features supported in 5G, and to support that, we have a function called as NSSF, which is network slice selection function. I hope you are able to get something. If you have any questions, please feel free to type in the chat box, and Miss Payal ma'am will read those questions for me. If you have any questions, please write those questions in the chat box. Now, a few enablers for 5G. We have already spoken about some of these things. Cloud native. It is going to be a cloud native architecture for radio as well as core. Ultra dense networks, lot of small cells, macro cells, micro cells, pico cells, homey node bees, repeaters, relays, and number of other stuff. Massive MIMO, you already had some session on MIMO and all. I'll not talk much on this. Wave, you already have a session, so millimeter waves, where we talk about higher frequency in the range of 20 to 100 gigahertz. MEC we are going to touch upon, which is typically bringing user plane closer to the end user, so that your QoE is typically called as consumer quality of experience. Just give me a second, I'll just have a sip of water. Sorry. So QoE is called a consumer quality of experience, which can be 5G also support D2D communication for public safety verticals, which is called as device-to-device communication. NFV, network function virtualization, which is decoupling the software from the hardware. We were talking about something called as VNF, virtual network function, in the last slide. So VNFs are actually created by using NFV, network function virtualization. SDN, software-defined networking, where we talk about control plane and user plane separation. Slicing, which is typically nothing but divide one physical infrastructure to multiple logical networks. We are going to talk a little more about it. Orchestration is end-to-end efficient management of the network. So in orchestration, we are going to talk about efficient management. And these are three things: MEC, slicing, and orchestration, where AI and ML plays a very, very important role. We are going to talk about how AI and ML are impacting these things. So typically, without AI and ML, you cannot really have MEC, you cannot really have slicing or orchestration. So AI and ML is something which actually drives all these things. Of course, massive MIMO is also playing a role into that. I mean, everywhere AI and ML is getting into 5G network, we will talk about it, how it is impacting our 5G network. Now, what are the global challenges? So if you see in 5G network, we are talking about speed. We are talking about signals, the coverage for everyone. Big data, the data what we are going to have is going to be humongous, right? So it's going to be really huge. Grabbing the data, processing the data, analyzing the data, and storing the data is going to be challenging part for 5G. How we are going to manage this, we really need to understand as we evolve. But this is going to be huge. The data is going to be huge. Internet, of course, one of the prime requirements for 5G network, different kind of network topologies, different kind of network technologies, and IoT, Internet of Things, and variety of traffic what we are going to have from 5G. So this is something what we are going to want with 5G. So we want so many other things from 5G in addition to these things which are mentioned. So what are the global challenges? The global challenges are bringing in the network operators, network manufacturers, and academia. So typically network manufacturers, which we typically call as OEM, or we call it as vendors. They were actually very stubborn from this early age of telecom. The OEMs were very stubborn, and they say for every technology you have to get a new hardware. However, the industry is pushing them to have softwareized network, and that's where network operators comes into play. They are pushing for the software network. If WhatsApp can provide voice calls without a lot of hardware, even Airtel or Vodafone, Airtel or Jio should be able to do that. So network operators are pushing for some software networks. Innovate and solve network problems with AI and ML, how to make your network more efficient, how to manage your networks in real time. That is something what we need to answer with AI and ML. We will talk about it. What are the things which are being supported in AI ML? So we need to implement AI ML architecture frameworks in 5G networks. We are going to talk a little more about it. Uncover problems, so understand the problems of the existing network and get a practical solution to those networks, those problems. So what we need to do is we have to understand the problems of the previous generation and then get a solution for the next generation networks. Now, 5G for Industry 4.0. So we are already talking about Industry 4.0, which is typically where we call it a connected society, and we say everything and anything is connected to the network. So now, reliable remote machine operation where you can operate your machines. So typically we take an example of this called as remote surgery. You may have something called as remote surgery. So we can actually operate those machines from remotely. Predictive maintenance, the maintenance should not be corrective, should be predictive. And so you already know that your network may need some kind of predictive maintenance. High precision positioning, if you really want to have URLCC kind of application, URLCC kind of application, which is called as ultra reliable low latency communication, the high precision positioning is going to be very important. Edge cloud, which is typically implemented by using MEC, multi-access edge computing, which was initially called as mobile edge computing, which later renamed as MEC, which is known as multi-access edge computing. We are going to talk a little more about it. So they are planning to implement MEC not only for industries, but multiple scenarios. So MEC is a very, very interesting use case for 5G. We're going to talk about a little more about MEC, and we will understand what are the different use cases for MEC. MEC is typically used in all the three service verticals, whether it is MMTC, EMBB, and URLLC. MEC plays a very, very important role in all the three use cases. So why I'm talking about this, we will surely talk a little more about it. We'll understand why MEC is so important. In case of cloud network or IT network, these MEC is something called as CDN. CDNs are called as content delivery networks. Content delivery network. What are CDNs and how do we really implement this in 5G? We are going to talk about it. Vehicle to X communication, V2X, vehicle to vehicle, vehicle to red lights, vehicle to anything else around you can be communicating to the vehicle. So this is something which we are planning to implement in 5G. Augmented worker or workspaces, all these things can be virtualized. The corona or the COVID-19 has shown us a different way to life. The way we are doing these things today are very different what we used to think maybe 6 months, 7 months ago. So the things are very different. Now we are talking about a lot of virtual workspaces where you want people to work from home, where you want to have these distance learning, online education. So the wireless networks are always going to play a major role in all these scenarios. Machine and process monitoring, all the machines and processes can be monitored by 5G kind of networks. Few quotation about AIML before we jump into AIML. Let us understand. Bill Gates says a breakthrough in machine learning would be worth of 10 Microsoft. Tony Tether, which is director of DARPA, machine learning is the next internet. ARPANET, which was the main leading body for internet, they say machine learning is the next internet. Machine learning is the hot new thing. This comes from the Stanford. Web rankings today. So whatever we do today I'm typing, I'm sending in a Gmail to Poornima College and I say, please find a test. And when I try to send that email, it says, hey, you have not attached anything, but you have written that please find a test. That means each and every message, each and every word what I'm writing in my email is actually monitored by Gmail. So Gmail is reading my each and every email and they know when I was planning to attach something. So tomorrow, this actually AI and ML actually getting into different direction altogether. So this is impacting our life. So the biggest two events which were actually supported by social media and AIML. One was Brexit, and another one was US election, where Donald Trump won. So there is a beautiful documentary on Netflix, which talks about, I don't remember the exact name now, but it is actually about how social media and how this AIML is actually changing our decisions. So they had around, so those agencies, there was an agency called as Cambridge Analytics in UK, they had around 5,000 data points. 5,000 data points for every individual voter in United States. So they show them what they actually want to see. So they were actually changing the thoughts, what they are thinking. So this is how the social media and AI/ML is playing with us. Now we are not talking about that aspect of AI/ML. We are talking about the network aspects of it. So how networks are going to play a major role. So what I'm trying to say here is web rankings, whatever rankings you see today is nothing but a matter of machine learning nowadays. Now, what is AIL? AIML? AIML, artificial intelligence, is a technology which enables a machine to simulate human behavior. Typically, sorry, we are actually having this human behavior and we want machines to simulate that human behavior. The goal of AI is to create a smart computer system which can solve the problems like human beings, because human beings are always smarter than machines. Now we want those machines to behave like humans, and to do this we need to have a number of other things in addition to ML, which is machine learning. So artificial intelligence, and a subset of artificial intelligence is something called as machine learning. Now, what is machine learning? Let's talk about it. Machine learning is a subset of AI which allows a machine to automatically learn from the past data without programming explicitly. So whenever we want to do, we want to have something to be done by machine, we need to program it. However, there is always a limitation on the programming. We cannot keep on adding program for each and everything. So what we want the machines to do these things without having explicit programming, and that is where they automatically learn from the past data, past inputs and past outputs. They will learn from that, and typically they will give you output. So typically what you write, what today I'm writing an email in Gmail, it actually tells me what is actually you want to type. So as soon as I say, hi sir, I write I am right. As soon as I write I am, it says, hey, I am Sanjay Kumar and so and so. So it keeps on actually tracking everything what I'm doing on the network, and it keeps on suggesting me new things. That is where AIML comes into play. Everything what we buy from market today is actually driven by the AI and ML. We keep on seeing ads and a number of other stuff. So everything is actually impacting these AI and ML is impacting our day-to-day life like anything. We cannot even imagine to which extent they are actually penetrating in our life. Right, but that's not the topic for the discussion today. We are going to talk a little more about it. So just want to give you examples here. Now, some of the samples of AI ML applications: web search, what we do, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social networks. Today, each and everything is impacted by social networks. We spend hours together on social media like Facebook, LinkedIn, YouTube, and WhatsApp, Telegram, and a number of other applications. So social media is actually having a big impact on our daily lives, right? So this is where all these AI and ML application comes into play. So almost each and every domain is impacted by AI ML today. So it can be some e-commerce, some YouTube streaming, Gmail, autonomous cars, some surveillance camera. Each and every service is nowadays impacted by AI ML. Now, deep learning is another aspect of AI and ML, where you can have n number of data points, where you can actually go deep into machine learning, where you have n number of data points and where you can actually make sure that how you can drive your autonomous cars. So this is just one very raw example of talking about AI deep learning. But deep learning is much more than this. So deep learning is actually getting more deeper into the machine learning, where you can collect each and every data points for the environments around you. So that is something what is deep learning. So we'll not talk much about deep learning, but just wanted to give you an example. So if you see here, these many data points you need to have for one particular car whenever you want to have an autonomous car. So you want to see road, you want to see buildings, you want to see sand or some potholes and a number of the stuff. So you need to collect so many data points, and that's where our deep learning algorithms comes into play. Now, just allow me a second. Okay. So what is intelligence? Intelligence is the ability to interact with the world. It can be speech, vision, motion, manipulation, ability to model the world and to reason about it, ability to learn and to adapt. So machines should be able to learn and adapt according to the changing situation. That is where intelligence comes into play. Just like our small kids, when they start walking, so they try to walk, then they fall, then they try to walk, then they fall, and one day they start walking. So machines are actually also learning at the same pace, and actually the higher pace than that. So we want these machines to learn and adapt. People say these machines are going to replace us and a number of the stuff. So we are not here to debate on that, but yes, this is playing a major role in our networks and day-to-day life. Ability to eliminate dull tasks. So you may need some rest, but machine may not need any rest. So we can actually eliminate the dull task from the human beings. Ability to solve the dynamic data. So we can have n number of different data points and we can collect huge amount of data and we can actually manipulate the data and can get best out of it. Ability to ingest huge amount of data. This is again a very important thing. These data points comes with a huge data itself, right? So big data we are talking about, big data to store this data, to process this data, to ingest this data, and finally analyzing this data and getting some useful insights out of the data is something what we need from the artificial intelligence. Now, what we are trying to do in AI with AIML in 5G networks. So in 5G network, our network management and network complexity can be fully automated. How typically we used to have OSS in earlier network, which typically have multiple options called as FCAPS, where F stands for fault, C stands for configuration, A for accounting, P for performance, and S for security. So fault management, configuration management, accounting management, performance management, and security management. And today, all these functions can be done by AIML. AI and ML or machine learning can actually automatically manage your fault, change your configuration, manage your performance, also manage your security, as well as manage your accounting part as well. In case of 4G network, we used to call them something called as SON. SON is called as self-organizing network. Self-organizing network. In case of 5G, we changed it a bit. We took it to the higher level, and now we call it as network orchestration. So in 5G, we don't really talk about OSS, BSS directly. Under that, there is another layer we have created, which is called as network orchestration, where your complete network is actually managed by automated AI and ML. Your whole network operations are actually managed by network orchestration. And network orchestration is nothing but lot of robots running inside your servers, which are actually managing your networks in real time. So network orchestration has a lot of interventions of AI and ML. We will talk a little more about it, but yes, just wanted to give an idea here. So AI ML is actually very much implemented in network orchestration. Individual network elements optimized to its specific operating environments. Also, it can allow you to use the network resources according to your operating environment. If you are in a big cell, you are in a small cell, macro cell, pico cell, and it can actually manage things. So for example, I am having a mobile phone and I am working in a campus in Bangalore called as Wipro campus. So as soon as Wipro have something called as MEC implemented, so as soon as I get into Wipro campus, what I will do is I will latch onto the Wipro network itself. And Wipro network will have completely different network architecture. So they will have their own standalone network for their employees. So I can use the services which are actually available in Wipro campus itself. So I can have network operating environments for different users. So every user can connect to different network operating environments depending on what are their actual usage. Cover all network technology generation from 2G to 5G and beyond. So 5G is not about replacing all the previous technologies, but yes, they don't really talk much about implementation, interaction with 2G and 3G, but they mainly talk about 4G and 5G interaction. The reason for that is 3G is more or less getting scrapped from the network. 3G is more or less getting scrapped, and now 2G is also getting little, I'll say, there are people, operators are not willing to spend money on that. So slowly, in a few years, even 2G will get obsolete. So what will remain in the network is again 4G and 5G. And I'm not sure by the time we scrap 2G and we already have 6G. So I can't really comment on that. But as of now, what we see here is we will have interworking network from 2G to 5G and even beyond 5G. So 5G is a technology which is not created as a stubborn technology like till 4G. 5G is created with a lot of flexibility. It gives a lot of flexibility to the users, lot of flexibility to the bandwidths and lot of flexibility to the networks as well. So 5G is here to stay, but only good. We can't really predict that, but we see 5G is going to be a big game changer for the telecom network. But let's see how these things will materialize on the ground. We are actually all excited to see that. But yes, we are expecting a lot of stuff from 5G, and how it is implemented in the network. For that, we have to see and we have to wait and watch for the things to happen on the ground. Some areas for AI and ML in network technologies. Network technology, we talk about radio algorithms, the advanced algorithms based on AI and ML, where we talk about this MIMO antennas, MIMO scheduling, and stuff like that. We are also talking about radio resource management optimization, RRM optimization. We are talking about power and energy optimization, positioning, network exposure. We were talking about something called as NEF, network exposure function. We were talking about NSSF, network slice selection function. That is where AI and ML are going to play a major role. How you will choose the slice. What are the things you're going to expose to the third party? These are the things where AI and ML are going to play a very major role. Now we will talk about some of these things in the next few slides. Network orchestration is also another classic example of AI ML. Network orchestration is incomplete without AI and ML, where networks are actually having self-healing. Self-healing means self-fault management. They can do the fault management automatically. Self-config, that means they can configure themselves. Self-performance management, where they can manage the performance of the network automatically. So all these things are not possible, cannot be possible without implementation of AI and ML. Network orchestration, edge computing, the optimization of capital expenditure and operational expenditure, management of slicing, security and privacy management. So this is again AI and ML plays a very important role. Interworking with multiple technologies, and of course the performance management, performance detection and performance management. These are the areas where AI and ML is going to play a major role. So AI and ML is going to be heart and soul of 5G network. Each and every component is going to be impacted by AI and ML. I hope this is something which you are clear with. If you have any questions related to this, please feel free to write those questions in the chat box. Yeah. Do we have any question here, Palma?
Right now, sir, no queries in the chat box. Participant, yes, please post your queries in the chat box.
Maybe another 10 minutes and then we will conclude the session, and then we can take all the questions.
Yeah. Sure, yeah. Sir, sure. Yeah.
Just give me a second. Okay. Now, moving on. So this is something, it's going to be a very important aspects of 5G network slicing. Network slicing means, what actually is network slicing? Let us understand. Network slicing, where one physical infrastructure is actually virtually divided into virtual networks. So one physical network and multiple virtual network, and all this is done with the help of virtualization. All this is done with the help of virtualization, where we are virtualizing all the infrastructure. But please understand, network slicing has to be end-to-end. So what does that mean? It will have a portion of radio network. It will have a portion of transport network, and it will also have a portion of core network. So if you really want to support slicing, all the radio network, transport network, and core network should be able to support all the slices. Then only slicing is possible. Now, what is slicing? Slicing are typically just 3 different applications. That is vertical. We have taken example, but there can be many more. So they have defined some slices like URLCC slice. So we have URLCC slice, which is talking to the URLCC. Sorry, this is the client here, and this is the server. So we have created a virtual network. We have created a virtual network on the same physical network, which is available for URLCC application, available for EMBB application, available for MMTC applications, and available for public safety applications. So what we've done here is, we have actually virtualized actually virtualized our physical network infrastructure. And this dedicated network slice is available for one particular kind of application. So I can have same user having multiple slice. I can also have one user having, like one slice, multiple users, one user, multiple slice, and n number of other options are available. So this is something which is nothing but dividing your one physical infrastructure into multiple logical infrastructure. One physical network into multiple logical networks. So every slice is a virtual network in itself. It's a virtual network, and which can be given to a service, which can be given to industry as well, which can be given to a MVNO, which is mobile virtual network operator. Tomorrow, the public safety applications like police, they want a slice for themselves. You can always allocate a special slice only to the police kind of application, only the ambulance kind of application. So we can have n number of possibilities where we can create multiple slices and we can deploy these slices for different services, different verticals, different industries, and different operators as well. So I can have multiple network operator, multiple virtual network operators as well, and I can give some slice to that. One important thing to note here, and one interesting thing to note here is, each slice is independent of each other logically. That means the services which is available here, for example, URLCC, in this scenario, I can have 1 millisecond kind of latencies. In EMBB, I may have 20 Gbps kind of download. In MMTC, I support 10 raised to the power 6 devices. So all these capabilities of these slices are going to be entirely different. I need not to have same capabilities on the slices. So basically, all the slices are going to have different resources available for them. And those resources are mostly kind of dedicated resources for that particular slice. But they are all created by you on the same infrastructure by using something called as virtualization technique. To understand this, we have to get into n number of other parameters. We will not get into those details as of now, but you need to get it supported by RAN network, radio network, transport network, as well as core network. Then only you can implement slicing. Right. Moving on, MEC in 5G. So this is a this is one of my favorite slides where we talk about market driver of MEC, challenges in MSC, characteristic and potential use cases and application of. So if you look at potential use cases, I have, okay, let me look here. I'm talking about connected vehicles, video analytics, big data. We are talking about V2X kind of application. I'm talking about local content caching, which is typically MEC kind of services where we talk about content delivery network. We are talking about AR and VR, augmented reality and virtual reality, where we are talking about EMBB application. Low latency application, we are talking about URLLC. So what I'm trying to say here is, we are actually trying to implement n number of services, and those services are only possible when you actually implement multi-access edge computing in 5G. However, we call it CDN in IT networks, content delivery network. In case of 5G, we call it MEC. And all the public cloud also have come with their own products which can support MEC kind of services. This one slide, I typically spend around 60 minutes to talk about. We don't have that much time, so I'll not get into those details as of now. This is a pretty interesting slide, and this talks about MEC in one particular slide. So if you really want to know more about it, please feel free to send me an email. I'll be more than happy to talk about these things. We don't have sufficient time to talk to take up all these things, but yes, this is a very, very interesting topic what we are going to have in 5G, 5G. Challenges, coexistence of distributed MEC and centralized cloud. Now what you want to this, if I talk about it as a layman, what I want to achieve in MEC. In MEC, typically our core network is a centralized network. It is at the center location. Now what I want is, I want this cloud infrastructure or this user plane, we typically call it as UPF, user plane function. And we want to bring this to the close to the user. So what does that mean? I bring the user plane closer to the user. First of all, because this user plane is closer to me, my latencies will be lesser. It will be less latency because now sending a request and getting a response of that It's very quick, so it reduces my latencies. At the same time, sorry, 1 second. At the same time, what it is going to do is, it is going to give me higher data rates because this user plane is only dedicated for n number of users which are available here, near to the user plane. So it also gives me a higher data rate. At the same time, it also enables me to have services like IoT, Internet of Things. So that is something what we are trying to achieve with MEC, and MEC is a very, very interesting use case. And going forward, we will see a lot of use cases for MEC in 5G network. So please, if you are really interested, please have a look at some more documents on MEC. It is a pretty interesting subject for 5G networks. Now, network orchestration, slice management and MANO. So if I talk about radio network orchestration, the network orchestration is something which is a different version of OSS. OSS is called as Operation Support System, which we were using in 2G, 3G, or 4G as well. So under OSS, we have something called as slice management, or I'll say MANO. MANO is called as management and network orchestration. Management and network orchestration. Now, this is also talking about the network orchestration cannot be done until unless it is end-to-end. Network orchestration has to be done end-to-end. So we need to have three different orchestration. One is radio network orchestration, another one is transport network orchestration, and the third one is core network orchestration. So radio network orchestration, transport network orchestration, and core network orchestration. What radio network does is it is managing the radio network. The transport network orchestration is actually the transport network orchestration, and the core network orchestration is managing the core network. Typically, the cloud infrastructure used to be orchestrated network. So in cloud infrastructure, there are a lot of functions and features available which can be automatically managed. Just to give you an example, in cloud we talk about something called as rapid elasticity. If you have gone through some documents on cloud computing and other stuff, so you have heard about rapid elasticity. What is rapid elasticity? Where you can increase or decrease the capacities whenever you want. You increase the capacity whenever you need more capacities, and you decrease the capacity whenever you no more you want it. So this is only possible with the help of AI and ML, where networks are actually monitoring your resource usage, and according to that, they can define some auto-scaling policies. There is something called as ASG groups, auto-scaling groups, where you can increase or decrease capacity at any point of time. There can be n number of other stuff related to load balancing, input, outputs, and a number of the stuff. So all these things are possible in the core network part of it. Transport network is going to be a little tricky. Now what we have is we have hard slicing, we have soft slicing, and we have different kind of network management. We have typically SDN based network. SDN is typically called as software defined network. So our transport networks are completely going to be based on SDN. Otherwise, you cannot implement your 5G efficiently. You cannot have hardware based transport network. You need to have software defined transport network, and then only you can actually afford to have 5G. In radio network orchestration, again, AIML plays a very important role. But here typically we talk about radio access bearer, where we keep on adding different bearer depending on the requirements what we have for a particular slice or particular service. So this is what we have for the network orchestration. And if you really need to know more about the core network and all, you can also visit our YouTube channel on on cloud computing. So there are a lot of interesting modules there. So I will be sharing the link of that. So if you're interested, you can visit that particular channel as well, and you can also subscribe for all our new videos. So we are coming up with cloud computing, AWS, Azure, and Google Cloud courses on in Hindi as well as in English. So I think it will be very helpful for you as well as for your students. So please feel free to share these links with anybody you want. That's all from my side. I hope I was able to add some value to your time. So that's all from my side. If you need any other information, please visit our website, which is www.nanocellnetworks.com, or you can email me at sanjay.kumar@nanocellnetworks.com. I will be sharing a link with you with this presentation, and you will be able to download that presentation by using this link. And if you have any questions, so I'm opening for the questions now. If you have any questions, please feel free to ask those questions. First of all, before I take questions, I just wanted to have a quick understanding from you guys. I hope you were able to like get some information out of it, and anything, any feedback, anything what you want to share in. I will appreciate if you can do that in chat box, like how actually you felt about this particular training, this particular session. I'll not say training. So allow me a minute. I'm just just give me a second. I'm just sharing some details here.
You can see the feedbacks in the chat box.
Yeah. So 1 second. Okay, you got a lot of information here. So just give me a second. So this feedback is not very important because I normally always take a feedback. So it's not mandatory to take this feedback. But if yes, you want to take this feedback, please do that. So I'll just go one by one. So first one is 1 second. I just missed it. Just give me a second. So it's not actually copying the complete information. So I have some links here. So if you want, you can actually go to those details. So I have a lot of sessions available on YouTube, which is about cloud as well as telecom. So if you want, you can actually visit those YouTube. So I've shared a feedback form, and I've also shared the presentation. The presentation is password protected, and the password is STTP 2020. 2020 is the password for the presentation. So if you need any password, you will use STTP 2020. So now I'm open for questions. Any question, any comments, any doubts, please feel free to ask. And I'm also very active on social media. So I've shared my LinkedIn profile. Please feel free to connect me on LinkedIn as well. Yeah, thank you very much. And thanks for listening me in afternoon session. I know it is very difficult after having a heavy lunch. And you are having this from last 4 days and another 1 day to go. So I understand those. And I really appreciate all the support, Payal ma'am and Garima ma'am, for calling me here and having this session. And I really enjoyed communicating with you all, and I look forward to have some questions from your side. Anything, ma'am? Anything you want me to answer?
Yeah, sir. One query is in the chat box.
Mm-hmm.
What are the major challenges that you can see India facing for the company implementing 5G networking?
Okay, so if you see now the biggest challenges what operators are facing is the volume of the users what actually going to get into 5G. And I see India is actually leading in that race. India, we are one of the country where we have more mobile users than anybody anywhere else in the world. So I don't see it as a challenge. I see this as an opportunity. Of course, the biggest challenge what we see here is the revenue, or I'll say the revenue streams which our operators are going to bring. And now if we see with the Geo coming in, the whole landscape of mobile operators have changed. Now they are no more the carrier and no more only the mobile carrier. Because earlier we were paying for voice and the SMSs. Now nobody wants to pay for voice calls and nobody wants to pay for SMSs, and everybody wants to pay only for data. And now what that brings another challenge to the operator to actually have more revenue sources. And that is where NEF kind of services are coming into play. NEF is typically network exposure function, where operators are going to have your data exposed to the third party. So they can give you the enhanced services. At the same time, they can generate some revenues out of it. That is something that I look as an opportunity, not as a challenge. So I see India is a very, very big prospective market for 5G, because we have a huge population to consume these data rates, and we have plenty of time to watch movies and videos on our YouTube channels or our Netflix Prime Video. That comes as, and you know, the typical one of the research paper I read, it says India has the highest population of the internet to user who have never touched computers, right? Because many of I'll say half of the consumers who are actually using internet have never touched computer. This is actually one of the very big opportunity for mobile operator, and I see this 5G as another big opportunity coming in. And how operators are going to encash this is again left to the time and how it will happen. But again, I see a very, very big opportunity. So I don't see India as a challenging market. I look at India as a very, very big opportunity market. So this is my brief answer to the question. Any other questions, sir?
Sir, I think no more queries. Yeah, one more query. Will 5G be compatible with 4G?
Sorry. So can you just say your question again, ma'am? I just missed a part of it.
Will 5G be compatible with 4G?
Yes, this is a good question. So 5G is going to be hand in hand with 5G, right? So for, initial deployments, all the initial deployments are going to be NSA deployments. NSA is called as non-standalone deployment. Non-standalone architecture means you are either going to use 4G radio or you are going to use 4G core network along with 5G radio or 5G core network. So 4G, of course, is going to be have a lot of interaction in interworking with 5G. And one interesting part here is all your 4G networks, especially in the radio part, if your hardware supports, they are actually possible to actually upgrade those hardware, where they can support 5G. So typically in 4G, we talk about our base station as E node B, evolved node B. There is a new definition which has come in 5G, which is called as NGEND. NG stands for Next Generation E node B, where your E node B can be upgraded to support 5G network. So you can directly connect your 4G E node B to the 5G core network, and that is where I see all the 4G network, 4G base stations are here to stay. Right, so they are not going to get scrapped. The only thing what I see is going to get scrapped is the core network, because they are already started talking about virtualization of core network. So both your 4G and 5G devices now are going to be implemented on cloud network, cloud native network. So I don't see the hardware boxes of 4G in the market. But yes, the BTSs, E node Bs, NG node Bs are here to stay. So they will take another 4 or 5 years to get scrapped.
Sir, many more queries are in the chat box. Kindly
Just give me a
refer.
second. So, okay.
Sir,
Yeah, just give me a minute. So password, somebody is asking for password. Password is STTP 2020. STTP, Short Term Training Program 2020. So I will share the PPT with the ma'am as well, so you can share on the WhatsApp group. I'm
Yeah.
not having any WhatsApp group. So
Yeah, sure, sir. Next query by the Chandni
yeah, I'm
Sharma. Will
just
prediction
allow me a minute,
system-
ma'am. I'm just reading that. Will prediction system vary with change of? Chandni, ma'am, can you just talk a little about prediction system? What do you mean by that? Maybe I'm not able to understand that, but just wanted to elaborate on that. Sir, frequency will be drastic variation. Then how it will be possible? Yes, the new age radios are going to support all these frequency. So your bands can start from as low as 400 megahertz, and it can go up to 40 or 50 gigahertz kind of band. So we are going to have very advanced radios, and this is how what we have to support. Because wave and all, they are going to support all these higher frequency waves. So we have to have those radios. So this is I'm not an expert in radio, frankly speaking. I don't know much about the radio part of it. But yes, this is something what they have planned already. Sir, which software or any lab where we can check 5G related real simulations? So I will share a link where you can actually have some. I'll not say they don't have all the application functions available, but I will share some links with the Garima ma'am, and she will share it with you, where you can actually have some of the application function which can be simulated. And I will also show you share some links where you can actually see the protocol messages of various interfaces of various network function in case of 5G network. Thanks for answer. What about cyber security mechanism once 5G implemented in terms of cyber law? Will cyber attacks will have different type? What industry and society face today? Dr. Nirba, very good question. Let me take this. When we talk about cloud network architecture, so there are two major questions which comes into people's mind. The first question is the pricing, how we are going to save money out of it. And the another one is the security part of it, how my data is going to be secure on my cloud infrastructure. Now, the pricing part I'm not going to discuss. Let me talk about the security part of it. First of all, the telecom networks, what we were using in 2G, 3G, and 4G were the most vulnerable networks when I talk about IP security. They had no security measures at all. So those networks till 4G are the most vulnerable network from the security point of view. So cloud networks are coming up with lot of security features, which you and me cannot even think of in 2G to 4G network. That is one. Secondly, when I talk about cloud infrastructure, I am saying cloud from the first slide itself. Let me put it this thing very straight. These clouds are not going to be AWS and Azure kind of clouds. No operators are going to build their network on. Ma'am, I hope we have time. We are not running out of time.
No, not at all,
Yeah,
sir.
yeah, because I just wanted to take those questions, and that's why.
Yeah,
Yeah.
sure, sir. You can take your time.
Yeah. So NSA cloud, I'm not really going to rely on the public cloud like AWS, Azure, and Google and stuff like that. Right. All the operators are going to implement their own data centers, and they are going to implement this as a private cloud. So now in private cloud, your private cloud is as good as your 4G network, where you have all the dependency available, all the security features available, whatever you want to implement. And the second thing is the kind of services and functions which are available for the cloud security is much more than what we can think of in the private networks which we had from 2G to 4G. So of course, it is going to in IP, nothing is secure. Anything and everything can be hacked. If a company like Facebook, a website like Yahoo can be hacked, anything and everything can be hacked. But when it comes to the implementation, there are n number of possibilities. They have DDoS applications where they can stop distributed denial of services. They have guard duty. They can have some computer audit where they can have trails, logs, and number of other stuff. So if you're really interested, I'll say you just go ahead and have one session, attend my session on my YouTube, which is about cloud security. It's a very, very good topic, and you will really understand how cloud security is going to be state of the art in cloud network, which is never possible in telecom network. So I'll say it is the other way around. It is going to be challenging, yes. Do we have some measures? Yes, bigger than that. So any telecom networks, whatever measures we had much bigger measure in case of cloud computing. I hope, Dr. Nirbe, I am able to answer your question. Mr.
Yeah,
Ms.
thank you very much.
Yeah. For machine learning, what we can use for machine learning, I'll say you can just go ahead and start writing an email. You are actually using machine learning. Go to YouTube and start searching for a video, and you are actually using machine learning. But if you really want to talk about implementation side, how you can actually learn, so I'll say just go ahead and look for some free resources on YouTube, and you can start learning it. You can. My daughter, who is actually 12 today, our kids are making apps, right? So yesterday, my daughter made a app based on the machine learning, and that machine learning, whenever you speak something, is actually writes converting your voice to the text is actually machine learning. Converting your text into the voice is actually machine learning. So you use Google Translate, that is machine learning. If you really want to learn it, there are n number of resources available. You can again send me an email. I will share some links also. So you can start learning machine learning the way you are. So like shopping system predicting users about their choices in advance. So Ms. Chani, let me take your question. So if you see, uh, shopping systems are typically nothing but machine learning. They carry your user behavior. They check what you were shopping in the past, what you were searching for, and there is a lot of concept of call as market. They call it redirected marketing. They call it cookies, which you can actually store in your whenever you open a website. It says we will store cookies in your mobile. So there are a lot of stuff related to this. So it's not only the cookies, not only the machine learning, but a lot of things related to this. Sorry. So shopping systems, they typically tell you what are the things you're looking at. A machine learning and AI plays a very, very important role there. So they see what are the things you are actually searching. And it's not only your mobile, all the mobile connected to that network. So for example, if my wife's phone and my phone is connected to the same Wi-Fi hotspot, if I am searching for something, I have to be very sure that my wife is aware about it. So then, otherwise, it can create some problem for me as well. So they actually track from where your data is getting out, because this is the same Wi-Fi hotspot which is used by me and my wife. So I can see what she's actually searching, and she can see what I'm searching. So all these things are actually connected to your the network, your cookies, and n number of other machine learning algorithms and other stuff. So I'll just take a very, very good example of this. I talk about social media. So I have like my social media account, and my wife also have a social media account. And on the social media account, I mentioned that I'm married to this particular lady, that is my wife. So now let's take an example. Today morning, I logged out of my Facebook account. I've not opened my Facebook account. So after I logged off, my wife posted something on her Facebook timeline. I have not opened my Facebook for next 5 days. But after 5 days, when I open my Facebook account, you know what is the very first post I will see? In those 5 days, hundreds of other friends have posted n number of other stuff. But you know, when I open my Facebook account, what is the first post I'm going to see? That post is going to be my wife's post. Because these computers are not only created with computers, they are created with a human emotion. As a person, as a human, we are always interested in our family, in our kids, in our wife, in our parents, brother. So they will always show you the content which is actually more suitable to you. So you actually get hooked to it. So the day I open Facebook after 5 days, it will actually show my wife's post at the first place. So this is again machine learning which comes into play. They actually map your human emotions to these computer algorithms. So I hope Chandni, I was able to answer your questions. If still not, please feel free to ask your question again. Ms. Monica is asking which criteria is used by mobile to select 4G and 5G. Ms. Monica, there are some kind of selection. There are some parameters which are typically, I'll say, typically transmitted by every base station. They are called as selection and reselection parameters. In GSM, we used to call it C1, C2 parameters. So mobile is searching all those frequencies, and in those frequencies, they are checking for C1 and C2 parameters, and they're comparing those C1, C2 parameters, and based on that, they're taking decisions when the frequencies are same. However, in my mobile, there is a setting which says prioritize 5G, prioritize 4G, or 3G, or 2G. So that also plays a major role how you're going to choose your network, either 5G or 4G. I hope that answers your question. Let me look at some other questions here. 1 second. Okay,
No more queries, I think.
password is STTP 2020. If you have any more questions, so Tani says, but algorithm and other requirements will vary with 4G and 5G machine. So what parameters is not that? So Tani, you see, now the network used to play. So actually we are mixing two things here. We are not talking about machine learning of the 4G or 5G network here. When you're talking about Amazon.com or Flipkart.com or their applications, I'm no more talking about the AIML of 4G and 5G networks. So they are just a carrier in this case. In this case, what is the AIML working here is not AIML of 4G and 5G network. But this AIML is working of Amazon servers, the AWS servers or Flipkart servers. So that they are playing a major role in showing you what actually you want to see. 4G and 5G have no role to play. They will play an important role when NEF comes into play. NEF is called as network exposure function. And network exposure function does what? When you enter into a mall, shopping mall, let's say Gaurav Towers in Jaipur, or some other mall in Noida called as DLF Mall of India, right? As soon as you enter into that mall, you get a SMS from Airtel saying that, hey, welcome to the Mall of India. That is where actually Airtel is actually tracking your location. So we have to understand this is very separately. We have to understand this is very separately that AIML of AWS servers or Flipkart servers and AIML of cloud or say 4G or 5G network. So we have to keep it separate and then understand it. I hope that makes sense, Chandni. Or any other thing you want to know? Any other questions? Please feel free to ask, and I will just share I will share my email address once again. If you have not noted it, just give me a minute. So if you have any more questions, please feel free to drop me an email or drop me a WhatsApp message. I will recommend you can visit our YouTube channel. I have a lot of interesting video on YouTube, much detailed video on 5G, and visit my another channel of Cloud Training Guru, which is about cloud training as well as AWS training. I hope I was able to add some value to your time, and please share your feedback in the chat box. Have you enjoyed it? Have you not enjoyed it? Or we welcome both positive and negative feedback. So even though you have some negative feedback, also please share. It improves. It helps us to improve our deliveries, our future sessions. And Garima man, thank you, and Payal man, thank you for all the coordination and all the support. And I really had pleasure like talking to all of you.
Thank you so much, sir, for the wonderful session.
Yeah.
Because really today's world is moving around the AI, ML, and cloud, and you delivered your session about the same.
Yeah. So I
Really, it
think
was very informative.
thanks
Thank you.
for giving me this opportunity to talk to all these. I mean, I was a little nervous in the start because there were so many doctors here, and I'm just an engineer, right? Really, so engineering was my last education, what I had, right? So I was a little nervous that so many eminent speaker has already spoken. So I was a little nervous. So I thought I try to add value wherever I can. Like, I hope I was able to do that.
Thank you so much, sir.
So
Thank you,
anything
Sanjay
else?
sir.
Yeah, anything else from my side, or we can close?
Yeah, just wait for the 2 minute one.
So,
Group
no
photograph
problem.
is there.
I'm available. I'm available.
Final first announce.
Yeah, dear participants, there is an announcement for you all. Tomorrow's first session is preponed by 30 minutes because of the sudden meeting of speaker. That's why you prepared yourself at 9:30 sharp. We will share the schedule on WhatsApp also. This is an announcement for you all, and I'll share the attendance link in the WhatsApp group also. Please fill your attendance for this session. Okay, and kindly turn on your cameras for a minute so I'll take a group photograph.
And ma'am, please share the feedback with me as well, right? So, I will be more than happy.
Sure, sir.
Sure. Done. I think thank you all of you. Thank you for your participation. Thank you so
Thanks
much.
everyone, and have a good day. Take care.